Good day and welcome back to our fifth and final installment dealing with lines and planes. At the end of the fourth video, I mentioned the idea that there is a worksheet that you should all spend some time going over. You can find that in Canvas. And what I would like to do in this video is kind of recap two examples on there that I think are really important problems to understand. So the first is the second problem on the worksheet. And I'll go ahead and note that the full solutions of the worksheet can be found on Canvas. So the other problems that we don't discuss, you can certainly compare your solutions to the solutions that I present. So the question here is, where does the line through a point and another point intersect a plane? Now, this is a much more general type of question than we might recognize. What we're trying to see is, where does some curve intersect a surface? So we are actually going to investigate this quite a bit more generally in the future. But for now, let's just think about what's going on in terms of a picture, something I always kind of encourage you to do. So I have a plane drawn, and then we want to know, where does some arbitrary line intersect that plane? And the idea towards kind of how we find that point of intersection is very simple in a sense. What we want to do is substitute the line into the plane and solve. But the key observation to go along with this is that when we substitute the line into the plane and solve, there's a certain form of the equation which is going to be extremely conducive to this problem. And what we want to do is use the parametric equations, because that would simplify things as much as possible. We'll have, as we will see in a moment, a single variable to solve for. So the first thing we need to do is come up with the equation of the line. So in order to come up with the equation of that line, we do have a point. What we need to do is come up with the direction. So I'll go ahead and I'll just let my point be 1, 0, 1. And the direction would be the vector connecting those 2 points. Intuitively, if we're at 1, 0, 1, I need to go 3 in the x direction, minus 2 in the y direction, and 1 in the z direction to end up at 4 minus 2, 2. So the equation of this line in vector form will be xyz is equal to the vector given by the point plus t times the direction. But knowing that we want to take this equation and substitute it into the plane, you need to have something to plug in for x, y, and z kind of individually. So that leads us to the parametric equations. X, if we equate coefficients, will be 1 plus 3t. Y will be equal to 0 minus 2t. And z is equal to 1 plus t. And what we would like to do is now substitute in to find that point of intersection. And just to foreshadow a bit, the point of intersection is really the key thing that we want to solve for. So we want to substitute into the equation of the plane. So x plus y plus z equals 6. So if we do that, we start off with x plus y plus z equals 6. X is 1 plus 3t. Y is minus 2t. And z is 1 plus t. And if we go ahead and simplify a bit on the left, we have 2 plus 2t equals 6. So if we subtract 2 from both sides, 2t is equal to 4. So t is equal to 2. And note, t equals 2 is going to be the parameter value that tells us where this line intersects the plane. So t equals 2 is not the point of intersection. It's not where the line intersects. It's the parameter value that gives you that point of intersection. So what we need to do is keep going with this. So we want to find a point of intersection. So we think when t equals 2, looking at this parametric equation of the line, what is x, y, and z going to be equal to? So x is equal to 1 plus 2 times 2, 1 plus 3 times 2, which is 7. Y is minus 2 times 2, which is minus 4. And z is 1 plus 2, which is 3. So our point of intersection is 7 minus 4, 3. So once again, kind of two more big picture observations. Whenever you possibly can, draw a generic picture representing the situation. It might just give you the intuition you need to complete the problem. Secondly, this is going to be a much more general question that we encounter later in the form of find where a curve intersects a surface. Okay, so I'd like to look at one more example coming from our worksheet, and I believe this is problem number 4. And once again, to start off with, let's just kind of think of the idea. We want to find an equation of the plane that passes through a point that we know. So we're thinking 1, 2, 3. And so I'm not going to try to be overly specific. I'll just say P naught is a point we know, and it contains some line. So let's let L be some line on the plane. Now, since we know our point, to find the equation of the plane, we simply need to find a vector normal to the plane. And the idea of how we can do this, if I can come up with, let's say, one point on this line, which we could do maybe by plugging in a parameter value. And the simplest parameter value I could plug in would be 0 or maybe 1. Then this will allow you to know two other vectors on the plane. And those two other vectors that we could get on the plane would be a vector going from that point on the line to the point that you know. And then the other vector could be, and for lack of a better name, I'll call it V, the direction vector of the line. Just make it so its initial point sitting at 0. And once you have these two vectors on the plane, you can take their cross product, and that will give you a vector normal to the plane. And so in words, the key idea is we simply need to find two vectors on the plane. And once you find two vectors on the plane, the cross product of those two vectors would give you the normal vector. So let's go ahead and see if we can put this into kind of equation form. So the first thing I want to do is note, what is this point on the line? And I'll just go ahead and call it L. And we can get a point on that line corresponding to any value of the parameter. And if we sit t equals 0, we see x is 0, y is 1, z is 2. So by sitting t equal to 0, we have x is 0, y is 1, z is 2. And this is telling us a point on the line is 0, 1, 2, and that's corresponding to this vector, or this point, when t is equal to 0. So the direction of the line we can read off by those coefficients of t when we are in parametric form. So the coefficients of t are respectively 3, 1, and minus 1. So the direction vector would be 3, 1, minus 1. And this represents a vector on the plane. What we need now is a second vector on the plane. So a vector on the plane would be the vector which goes from the point on the line, 0, 1, 2, to that point 1, 2, 3. And just to give it a name, let's go ahead and call that vector b. So if we're at 0, 1, 2, I need to go 1 in the x direction, 1 in the y direction, 1 in the z direction to end up at the point 1, 2, 3. So a normal vector to our plane would be the vector v crossed with b. Because remember, the cross product of any two vectors on the plane will give us something normal to the plane. So 3 by 3 determinant, ijk, we have the vector v in the middle row, b in the bottom row, and a couple quick computations gives you 2 minus 4, 2. And note, if you went about this using maybe a slightly different method, which would be perfectly fine, there's many ways to do this problem, you may come up with a slightly different normal vector. And that's fine, as long as your normal vector is a constant multiple of mine, or as long as my normal vector is a constant multiple of yours, we'll say, we're all good. So now we have the normal vector, and we have a point on the plane. Putting this together, we have the equation of the plane. So we're going to say 2 times x minus 1 minus 4y minus 2 plus 2z minus 3 is equal to 0. And let me just finish by noting that you've hopefully observed through working on the worksheet and discussing some of these examples, hopefully even by going to the book and working suggested problems, that these examples dealing with lines and planes can be quite challenging. So I recommend drawing a generic picture representing the situation and really going back to these fundamental principles. You always need a point and then either a direction for a line or a normal vector for a plane. And remember, if you have questions, do not hesitate to drop me an email, stop by the virtual office hours. So stay tuned and take care.